unit circle has radius 1. So what do you suppose a vector with magnitude 1 is called? Yeah, the unit vector. Correct. Unit vector. Okay? So it turns out, like in our little animation here, there are many values of C that we could pick, right? Positives, negatives, small and big, to make different size vectors, right? But if we choose to multiply our vector by 1 over rad 13, like this, I promise you that thing's 1 unit long. You want to see why it's 1 unit long? Watch this. There's your unit circle. Fits beautifully, doesn't it? So what did I multiply my vector by? 1 over rad 13. It's kind of like if I said, I would like to create a miniature version of this stapler. Okay, I want to make a miniature version of this stapler. I want to make a unit stapler. What would a unit stapler's length be? Naturally. Unity, uno, uniform, nine, 1. Okay, so first you want to know how long the stapler is. So let's see. The stapler is 6.5 inches long. So I would multiply every dimension on the stapler by 1 over 6.5. And then you have this tiny little stapler called a unit stapler. It's exactly, not 6.5 inches long, 1 inch long. You guys understand that? Or you can make a unit marker. But you got to divide that marker by its own magnitude. So first you got to know the magnitude. 5 inches. This is the 5 inch marker. I would want to divide every dimension by 5, or multiply every dimension by 1/5. And then I'd have a little tiny unit marker ready to hold in my hand. You guys understand? So you measure, and you divide by that number. Okay. That's a pretty simple principle, but it was really confusing to me when I first learned it, because nobody took the time to show me this picture and what actually happened. Our vector shrunk and fits beautifully into this unit circle. Okay, another thing that you might want to consider is, what if you had a really short vector? So let's say you had a tiny vector like the vector 1/2, 1/3. So let's say you had a tiny vector 1/2, 1/3. Okay? Now this vector is too short to fit in the circle. But this is the vector we have. So it's 1/2, 1/3. I'll write that on here. I'll use red. So this is the vector 1/2, 1/3. Notice it's a little bit wider than it is tall, because 1/2 is actually a little bigger than 1/3 is, right? But I would like it to be 1 unit long. I think dividing it by its own size would make it smaller, right? You think that. But listen, its size is less than 1/2. So if you divide this by its own size, it's actually going to grow. So watch this. We said we can always make a unit vector by dividing a vector by its own size. Let's see if that works here. This is kind of weird. This one's already too small. If we divide it by its own size, will it grow? Yes. Watch this. How do you find the magnitude of the vector? Correct. So you just square these, add them, square root. It's going to get a little awkward. Okay? You're going to be finding the magnitude first. This is like measuring it with a ruler. When I did the stapler, remember? So first we're going to measure it. So how long is that thing? Awkward. That's awkward. Okay. The promise was, though, that if I divide the vector I started with by its own size, it would be 1 unit long. Let's see if it's true. So Mr. Shor's can enter into his computer for his C value 1 over 13 over 6. I'm going to divide by its own size. So I'm going to type in, I guess I'll type in 6 over rad 13. This is like dividing by the magnitude. Perfect. So it feels like I stretched it, but what I definitely did do, I stretched it. In some cases I'm shrinking, but what I'm always doing is dividing it by its own size. Anytime you or whether it was too short and now it's longer, or whether it was too long and now it's shorter. Okay, so going back to the notes, what I'm saying is, anytime you have a vector and you divide it by its own magnitude, you're going to get a unit version of that vector. Okay, so we have symbols for everything in math. You know that. This V harpoon is pronounced vector V. The double bars on the V harpoon is pronounced magnitude of V. This is a brand new symbol. This is pronounced V hat. V hat. Like V with a hat on. I'm not kidding. That's the official name. Okay? This is called V hat. Does anyone speak Vietnamese? Okay, I've heard that this symbol in Vietnamese is also pronounced hat. If you see one of these on top of an English letter, or a romanization of Vietnamese uses English letters, if you see one of these on top of a letter, you're supposed to pronounce it hat. Is that true? That's what I heard. It's not true? It's not the hat symbol? Okay. Has a radius 1, or a length 1. So that hat always means magnitude 1. Okay? So how do we create a unit vector? We take a vector, we measure it and find the magnitude. Right? Then we divide that vector by what? Its own magnitude. And that pops a unit size version of it. Now notice in my little animation here, the direction of my vector is perfectly preserved. See that? Like that vector has the same direction that it had before I stretched it out. You guys see that? That's a very important property of unit vectors. They don't find a new direction. They just are same direction. Magnitude is 1 now. Very, very important. Okay. Okay, now if you see this vector, 1, 0, 1, 0, right here, that means it means run 1, rise none. It means run 1, rise none. What exactly would that look like? I think you would just go like this, wouldn't you? One space over? Okay. And this other one means run none, rise 1, right? Okay, these two guys are quite popular. I mean, there are many unit vectors in the world, okay? All pointing different directions, you know. There's actually an infinite number of these guys. Some point up, some point down, some point left, some point right, some point diagonally. There are many unit vectors in the world. But these two guys are famous enough, I guess, to get a name. The first guy is called I hat, and the second guy is called J hat. They got names because they're sort of the most popular of all the unit vectors. They're the celebrities of the unit vector world, you could say. They're like thing 1 and thing 2 from the Cat in the Hat. Okay? They're main characters in the story. Alright? Just memorize that. I hat means 1, 0. J hat means 0, 1. Okay, so we're going to do a quick exercise to verify that really any vector can be thought of as a certain number of i's and j's. A certain number of i's and j's. Okay? So first I'll do this with the vector 3, 4. 3, 4 is a great vector. It's simple to understand. It's right 3 up 4. Isn't it true that 3, 4 can be thought of as 3, 0 plus 0, 4? Now you know how to add vectors. So you shouldn't be surprised that I can split them back up again. Isn't it true that 3, 4 could be written as the vector 3, 0 plus the vector 0, 4? What do you get when you add those back together again? 3, 4. Okay, so it's a legit split, right? Okay. Isn't it also true that we can pop the 3 out of this first one and pop the 4 out of the second one? We talked about that yesterday. We said pulling a number out of vectors just a perfectly acceptable thing to do. Okay. And if these we just basically wrote the vector 3, 4 in terms of the very famous I hat and j hat. You can do this with any vector. Every single vector on the planet can be written with i's and j's. Now, to generalize this, so that we don't think it only works with 3 and 4, let's do it with a and b. And I'm not going to tell you what a and b are. We're just going to let a be a and b be b, and they just mean two numbers in general. So we always try to do things with the general case. Isn't it true that we can take a, b, and write it as a0 plus 0b? Isn't that legit? Is it okay for Mr. Short to do that? Can I take a, b, and write it as the vector a0 plus the vector 0b? Thank you for catching my error. This is a 4. It's a copy error. So sorry. That was a 4. Okay, so back to this discussion over here. It's true that we can write any vector AB as a0 plus 0b, right? Which means we could then pull out the a from the first vector and pull out the b from the second vector. And these are your thing 1 and thing 2, main characters in the story of unit vector. So this is a I hat plus b j hat. So now I'm not using a particular a and b, I'm just saying it's true in general. A comma b, in brackets, is also a I hat plus b j hat. In other words, it's legit new notation. So this is a brand new notation to add to our already long list of notations. Thus, we introduce a new notation. AB can always be written as AI hat plus BJ hat, and this is called unit vector component form. Now, let me say something about this format. The IJ thing is a very old tradition. Okay, it goes back hundreds of years. All right? And it's a little unfortunate that it survived. I will always default to this notation. I like this notation better. I'm going to use the brackets as often as possible. There's a couple reasons for that. First, it's easier to write. Second, this plus right here doesn't mean add. It doesn't mean add. That plus is a placeholder. It's a separator. It just separates the i's from the j's. It's really more of a comma. It's a very unfortunate thing we write it as AI hat plus BJ hat. It would have been so much better if it had been written AI hat comma BJ hat, because the i's and the j's never combine. Okay? You guys understand that? There's no addition here. It's not really addition. It's more of a comma. It's a separator. So I hate that plus there. It's really hard to explain to students that that's not an addition. It's a placeholder. So I'll always default back to the AB, but you need to know about this notation because your physics book is covered with this stuff. The scientists use this all the time, i's and j's. Okay? Okay. So anyway, one last comment about I. Remember we said I is the main character in the story, right? He is the vector 1, 0. And he looks like this. One unit long. The reason he's such a main character is because he's sort of the horizontal, go to the right unit vector. You know what I mean? He's like the only unit vector in the world of unit vectors that actually points rightward. So I can see why he's pretty important. Rightward is pretty important, isn't it? It's our positive x direction. J hat is famous because, well, it's 0, 1. And it points which way? Straight up. So he's sort of responsible for advancing you upward in life. You know what I mean? So I can totally see why I and J became so famous. I moves us right 1, J moves us up 1. How is that not important? I guess that's important. So I can see why it's an important notation, but it's awkward with that plus there. It doesn't mean plus. It means more of a comma.
want to make too big of a deal of it. Once you start writing your answers and stuff to worksheets, you'll be fine. But notice we have a lot of notations. So now let's go to the generalizing of unit vectors. So it's always possible to think of any vector u as a scaled version of its own unit vector. Okay? Remember the stapler analogy I gave you? That wasn't really a very good example. The reason the stapler was kind of a lame example is because a stapler is a three-dimensional object. But a vector has how many dimensions? A true vector has how many dimensions? If you hold it in your hand, does it feel like a point, line, plane, or solid? Line, one dimension. Okay? We laid it on a two-dimensional surface. Just like we place 3D objects in our three-dimensional world, and we lay two-dimensional objects in our three-dimensional world. But actually, a vector itself is a one-dimensional creature. It has only a length, you see. And you set it down on a grid, and it appears to have a width and a height, but it's really just itself just a one-dimensional creature. You guys understand that? It only has a length. So when you divide it by its own magnitude, it shrinks to unit size 1. Okay? But there are no other dimensions that get shrunk. Remember the stapler example? I was saying we'll divide every dimension by 6.5. Well, then you're going to get a stapler that's like really not tall, not long, and not wide. It's like a really cute little stapler. And I wouldn't say that 6.5 of those staplers makes up one of these. If you took 6 of those tiny little staplers and you put them together, it doesn't even look like a stapler anymore. It looks like 6 tiny staplers. You understand? But with vectors, what's interesting about them is because they're little one-dimensional creatures, let's say you have a long vector that's 7 inches long, and then you shrink it down to be 1 inch long. You could think of the big 7-inch vector as 7 1-inch vectors. If you stack 7 1-inch vectors together, you cannot tell the difference between that and a 7-inch vector. Okay? So the stapler wasn't a great example because it's a three-dimensional object. But think of it this way. What I'm saying in this is this vector here, how long is the vector 3, 4, class? How long is the vector 3, 4? If you actually measure with the rule, it would be 5 units long, right? 9 plus 16 square root. Okay. If you pull the magnitude out front, this right here is the unit vector. Okay? So what's going on is we have the vector 3, 4. We pop the magnitude out front, and now we've got the vector 3/5, 4/5. That little guy, that little 3/5, 4/5, he's a unit vector. You can check if you want, but his length is 1. How do I know? Because I divided out its magnitude. See how I divide by 5 on these? Okay? So what I just circled, or excuse me, what I just boxed, is the unit vector. So in other words, the vector u can be thought of as 5 little u hats. You see? That's what this statement is saying up here. 3, 4 is the same as 5 times 3/5, 4/5. Naturally, the same thing. You redistribute this, you get 3, 4. But by popping the magnitude out front, I can think of 3, 4 as 5 of these little 3/5, 4/5 vectors. You see? And this is true in general. You can always take any vector AB. You can take any vector AB and think of it as its own magnitude times its own unit vector. So what you're looking at here is kind of cryptic and confusing, but let me circle some things for you. This is vector u. This is its magnitude, and this is its unit vector. And this relationship will always hold true. That a vector can be thought of as its unit vector times its magnitude. Some people like to write it like this. Look on the next page. Some people like to write it like this. The unit vector. They like to write u hat like that. They write the vector AB, and then under it, they write the magnitude, square root of A squared plus B squared. Some people like the tidier notation, and they like to write it like this. They're literally just writing U divided by its own magnitude. That's U hat. However you write it, it's a unit version of the vector you started with, and it's called the unit vector in the direction of U. So it's called the unit vector in the direction of U, or we simply call it U hat. Okay? So there are lots of things I could write. I can write this statement at the bottom here, that U is just magnitude times U hat. That's true. You can isolate the U hat and write it this way. U hat will just be U divided by its own magnitude. However you want to shuffle it all around, it all means the same thing. When you divide a vector by its magnitude, you get a unit vector. When you take a unit vector multiplied by its own multiplied by the magnitude of another vector, you get that other vector. So there's a lot of different ways of thinking about it, but ultimately this is a little formula that you're welcome to use whenever you want. You have to know what all the symbols mean now. What do the double bars mean? Magnitude, right? So it really means Pythagorean theorem. Okay. So I always thought that was a little hard to explain to people, and hopefully between the animation and the stapler example and everything, it kind of makes sense to you. So now we have all these different notations, and it's time for a class chant. Okay? So you have a couple typos in your class chant. First of all, this should have said parentheses right here. I think you guys have the word bracket there. Please change that. So right there, the last part of the sentence, it says U times bracket. That should say U times parentheses. Okay, so why am I doing a class chant? It's because if you can't pronounce it, or if you've never pronounced it yourself, when I say it, you're going to be like, what's going on in this classroom right now? So let's just say it all out loud together. Our goal is to be able to read the top line without peeking at the sentence. But for now, let's just read the sentence slowly and sort of keep an eye on this part in yellow right here. So keep an eye on this as you read the sentence. Okay, let's read it out loud together. I think it's important. Ready, go. Vector U is bracket A, comma, B, or, so that's the equals. Or another way of writing U is, that's what it means. Okay, go on. A, I hat plus B, J hat, or magnitude of U times bracket cos theta, comma, sine theta, or magnitude of U times parentheses cos theta I hat plus sine theta J hat. So that's a mouthful, right? But let's see if we can say it again, this time without even looking at this sentence. So, try to actually not even read, not even look at this here. Read the math symbols in English, Let's try it. I'm not gonna say anything, so your turn. Ready, go. So I always thought it'd be cool to record that and then speed it up and make it sound like hamster voices. Hey, I have it recorded. Maybe I will. No, I won't. I won't embarrass. But it'd be kind of funny to hear. All right. So anyway, why did I have you pronounce like bracket and parentheses? It's because when we use the hat notations, we don't use brackets. See that? And when we use the brackets, we never have I hats and J hats. So there's a reason for that. It's mainly historical, but I've seen students try to combine the brackets and the I's and stuff. It's either brackets, diagonal brackets, also, when we get into the 3D stuff and we include I hat, J hat, and K hat, so I, J, K, oh, I'm not kidding. Like, I'm just kidding, but when we have I, J, and K, we'll see that it's important you've seen these notations and you're comfortable with these notations. So, we don't want to get confused at any point here. Let's read these last two sentences also. So obviously this first one's pretty easy to read. It's just U, vector U is magnitude of U times U hat. But it's the sentence after it that's important, so you understand what it's telling you. This sentence is shouting a truth. Do you understand that truth? Well, here's what it's trying to tell you. So let's read it out loud. Here you go. So vector U, start with vector U, go. Vector U is its own magnitude times its own unit vector. Okay. So what does it mean? Go on. A vector is a scale version of its own unit vector with the same direction. Okay? The next one is just the same equation, I've just isolated U hat. Okay? But it reads, why don't you try? Go ahead. U hat is... No. The unit vector for U, let's pronounce it for what it means, right? So go ahead. The unit vector for U is the vector U. Good. So that's what I would have said too. I would have said the unit vector U is the vector U divided by its own magnitude. Okay? And what is the sentence telling us or teaching us? Ready to go. The unit vector is the scale version of the original vector. Points in the same direction. All right. See, I could have made you create those sentences yourself, but it would have been hard to do. Okay, so now you're ready to finish that exit ticket. At the bottom of your exit ticket, you will see it talks about finding the unit vector for A. And that's our last activity, so I want you to find the unit vector for A. I noticed that I was supposed to kind of have been going a little faster here. I was kind of supposed to finish most of that yesterday, and I didn't. So what I'm going to do is postpone the quiz till Monday. It's not because of the assembly, it's because of myself. Just going a little slower than I hoped. But you won't feel good about the quiz if I push you. So let's do the quiz Monday. I know it's another day, but that just means you have 35 minutes instead of 55 minutes. It's still a short quiz, and I promise to let you do the 9, 5, 9, 6 problems at home. That promise still stands. You can do those Monday night at home.